Thank you. As mentioned, my name is Richelle Gore and I work with ImpediMed as a project engineer. In this presentation, I hope to provide you with an understanding of the science and methods behind the bilateral L-Dex score measured using bioimpedance spectroscopy. Bioimpedance is a useful and reliable tool for the assessment of lymphedema. This is because the measurement of the impedance is an indication of the fluid present in a limb. The applied current will flow primarily through the fat-free mass and fluids rather than fat or bone, which act as insulators. Bioimpedance spectroscopy in particular has the ability to detect changes in lymph or extracellular fluid because of the effect of frequency on the measurement of impedance. The SOZO measures the impedance at 256 frequencies between 3 kHz and 1000 kHz, and the response for biological tissue is represented by what is known as a Cole plot shown here. At high frequencies on the left of the graph, the current can pass through the cell membrane and the impedance represents the total fluid present. The Cole plot is used to determine this impedance called R infinity. At low frequencies on the right side of the graph, the current cannot pass through the cell membranes and the impedance represents the extracellular fluid only. This is called R0 and is also calculated using the Cole plot. It is this value that is vital in assessing the presence of lymphedema, as BIS is able to distinguish extracellular fluid changes only. As the amount of extracellular fluid changes due to an increase or decrease in lymph, the R0 also changes. By comparing the impedance of the extracellular fluid to a healthy control limb, we can assess for lymphedema. As presented during previous webinars, we use this knowledge to determine an L-Dex score for unilateral lymphedema by comparing the impedance of the extracellular water of the at-risk limb to the impedance of the extracellular water of the healthy contralateral limb, as we assume this limb remains stable. That is, for example, the left arm is compared to the right arm, or the left leg is compared to the right leg. In the case of bilateral lymphedema, however, we no longer have a healthy contralateral limb to compare to. Instead, we use the ipsilateral limb as the healthy control limb. So in the case of a left arm, we compare it to the ipsilateral left leg, and in the case of a left leg, we compare it to the left arm. In each case, we start by calculating the impedance ratio of the unaffected limb to the at-risk limb. In a healthy population, the distribution of the impedance ratio for the contralateral limbs and the distribution of the impedance ratio for the ipsilateral limbs are different, and we can see that in the image here. In the healthy population, the average contralateral limb ratio, as used for unilateral L-Dex scores, is close to 1, and the variation within the population is relatively small. An example for the contralateral limb impedance ratio for female arms is shown in blue on the graph, and you can see that the standard deviation is small, centered around the mean of slightly greater than 1. This makes sense given the similarity in resistivity, cross-sectional area, and length between the limbs being compared. Both healthy arms are very similar. In the case of bilateral lymphedema, however, when the ipsilateral limb ratio is used, the ratio of the leg to the arm is not so close to 1, and the variation within the population is greater. This is demonstrated in red on the graph for the impedance ratio of female leg to arms, where the mean ratio is less than 1, with a larger standard deviation and wider spread. In this case, the arms and legs are not similar in cross-sectional area, and the ratio of arm to leg length significantly varies in the wider population. Some people have long legs compared to their arms, while others have shorter legs compared to their arms. This shows very clearly that although both unilateral and bilateral lymphedema is assessed using an L-Dex score, they are calculated differently and compared to different healthy populations. This means that the unilateral L-Dex score and the bilateral L-Dex score will not be equal for the same at-risk limb. To calculate a bilateral L-Dex score, we first measure all 4 limbs, that is both arms and both legs. Using the SOZO, this is very simple, as a patient stands on the device without shoes or socks, and the impedance of all limbs is measured in a single measurement. The impedance of each limb is measured at the 256 frequencies, and the impedance of the extracellular water, or R0, is determined from the Cole plot. So we have an R0 value for the left and right arm, and for the left and right leg. If we are taking a bilateral arm measurement, the R0 ratio of each control leg to ipsilateral at-risk arm is calculated. If we are taking a bilateral leg measurement, the R0 ratio of each contralateral arm to ipsilateral at-risk leg is calculated. The ratio of the R0 value for the healthy to at-risk limbs is compared to the mean and standard deviation of a matched healthy population by gender and dominance, and the L-Dex score is calculated for each affected limb. This allows the L-Dex score to be compared across populations, such that a change in L-Dex score represents the same change regardless of the gender, limb, or dominance of the subject. This is also true for a bilateral L-Dex score. Although bilateral and unilateral L-Dex scores are not measuring the same thing, the bilateral L-Dex scale represents the same shift in standard deviation of the equivalent healthy population as a unilateral L-Dex scale does. That is, plus 10 and minus 10 represent 3 standard deviations above and below the mean, and a shift of 6.5 L-Dex units is a shift of 2 standard deviations. For the bilateral L-Dex scores, 95% of the healthy population will fall between minus 6.7 and 6.7. So let's have a look now at a demonstration of a bilateral measurement. First, we set up the profile for the patient. We choose the L-Dex analysis for lymphedema. We choose the assessment type for bilateral. The body element in this example is for the legs. And the at-risk, well, both legs are at risk, so left and right is chosen. And the limb dominance in this case is the right leg. We're then presented with the details of the patient, and we choose to measure that patient by pressing the measure button. Before we measure the patient, we enter the weight of the patient, which is important to be accurate when we look at the body composition, the tissue and fluid analysis parts of the results. So the tutorial is shown where we show how to place the hands and feet on the device to get good contact and a good measurement quality. We press the start button, and again we have that 5-second countdown, so there is time for the patient to settle. This is when the impedance measurements are taken. We sweep the right side and the left side, and we take all 4 measurements at the same time. We're then presented with the L-Dex score. So we get an L-Dex for the left leg and also the right leg, and then we can see the history for each of those legs of the bilateral measurement, the left leg and the right leg. And the history graphs come in most useful for tracking, obviously, but when we can set a baseline measurement, we can actually track the change from that initial baseline measurement. So we do that by going back to the history and selecting a measurement as the baseline. Now this can be a different measurement for each leg, so it doesn't have to be the same measurement on the same day. You can choose a separate measurement for the left side and the different measurement for the right side. In this case, we'll just use that first measurement that we have taken. So we've set the baseline for the left leg, and then we do the same thing. We scroll down and set the baseline measurement for that right leg. And that's been updated. So then when we go back to the results screen, we're presented with our L-Dex scores again. But this time, when we look at those L-Dex scores, we can see that we have a baseline set. So that vertical black line is the baseline, and we can see the score of 2.7. It presents us with the baseline that was actually 0.2, and also the change from the baseline of 2.9. So in actual values as well as visually represented on the graph. So that's for the left leg and the right leg. And then again, we see those history charts where we've got that constant line, which is the baseline. So we can really track that change over time for both legs. What's also important to consider when we look at a bilateral measurement is the col plots. Now, if everything goes well, we'll get green, high quality plots for all of the limbs. But if there's any concern, we can always review those col plots, and we can check in particular what's important is the left leg, the right leg, the left arm, and the right arm. So those limb measurements we want to be high quality to ensure that our bilateral measurement is the best quality it can be. So, bilateral measurements provide an L-Dex score for 2 limbs and are therefore best suited for patients who have both contralateral limbs at risk of lymphedema, not in the case of 1 limb at risk. We really want 2 limbs at risk. As in the case of a unilateral L-Dex score, the fluid status of the control limb is important to consider. So, for the bilateral measurements, if the arms are at risk, then we need to make sure that the fluid state of the legs are considered. Again, if the legs are at risk, we need to make sure that the fluid state of the arms are at risk, because any change in the fluid state of these control limbs can affect the L-Dex score. Because the unilateral and bilateral L-Dex scores are not calculated in the same way, they won't be equal when compared for the same at-risk limb. They compare to different control limbs and use different equivalent healthy impedance ratio distributions, and therefore cannot be compared directly. Healthy patients who have similar length and sized arms and are close to the mean will not necessarily have the same relationship between their arms and legs. The ratio of arm to leg impedance may be closer or further away to the mean than the ratio of the arms, and so the L-Dex score will differ. Because of this, it is not advised to take both a unilateral and bilateral measurement for the same limb. The L-Dex scale, however, still represents the same amount of change in standard deviations for all L-Dex scores. That is, a 6.5 unit shift represents 2 standard deviation shift for all L-Dex scores. Again, the ability to set a bilateral baseline measurement for each limb allows individualized tracking per limb. It shifts the trigger points of the L-Dex scale specific to each limb and allows monitoring of the limb, which in turn identifies the earliest opportunity for intervention and treatment and better patient outcomes. So I'd now like to pass the presentation on to Marie O'Connor, who will present her clinical findings using the SOZO for bilateral lymphedema. Thank you.